So we are on to point 7a, and this is inequalities involving absolute values. So in the last section we did equalities with equal sign. Now we're going to do inequalities. So let's look at what we've got here in the box. If the absolute value is 7, the absolute value of x is 7, that means that x is 7 units from 0 on the number line. So that means that x is either here or here. And this distance here is 7, and this distance here is 7. So x is 7 units from 0 on the number line, which means that we have two different possibilities for x. We have a negative number and a positive number, which in this case is -7 or +7. Now on this next one, we have a. Exactly the same idea, only we've got inequalities here. This means that a is less than 5 units from 0 on the number line. So in the one before, it said that x was exactly 7 units. There's no variance. But on the next one, it says a is less than 5. So if we're here at -5 or we're here at +5, we don't care what a is as long as it's less than 5 units from 0 on the number line. So that means that we are talking about all the numbers this way up to 5, but not 5. So we're going to put the rounded there, or any of the numbers to the left of 0 to 5, and we're going to put a round there because it says the absolute value of a is less than 5. It cannot be equal to 5, so therefore we had to round. The other option is, let me get my handy dandy, whoa, things aren't erasing here. All right. So the last one gives me a number line, and I'm at 0, and it says 4. So what is that telling me? That means that y is a number greater than or equal to 4 units from the number line. So y can be a number this way, because anything to the left of -4 is more than 4 units, because -4 is 4 units, or this way. And these are going to have the squared because it says greater than or equal to, which means it can be 4 units away from 0. So we're just graphing both ends of that number line there to make that work. Okay, so before we move on, let's do something else here with this first one, with the absolute value of a is less than 5, which again means that a is less than 5 units away from -5 as well as 5. So if it's less than 5 units away, it's going to be here, and it's going to be less than 5 units from this 5. Therefore, we make rounded because we don't want to include 5 because it's less than 5 units away. And we could also write this as that. So what we do, we take this and we take this and put it at either end, and the variable then goes in the middle because a is somewhere between this number and this number. So let's look at example 1. Okay, so we're going to write this very similar to what we did with the equalities, that 2x minus 5 is less than 3 units away, or 2x minus 5, or less than 3, or less than negative 3. So again, if we draw our number line, we have 0. We're saying that 2x minus 5 is less than 3 units away from 0. So 2x minus 5. We're also saying that 2x minus 3 is less than 2 or 3 units from 0 on the number line, and it could be left. So we could write this as 2x minus 3, or 2x minus 5 is somewhere in that range there. So if we were to write this with our inequalities like we did earlier, I could do that, 2x minus 5, and I can do that. And this is going to be less than, this is going to be less than. These signs will always point the direction they are, and they will always point the same direction. So that makes it a little bit easier when you're doing that. As you know, they're always going to be less than signs. So now I've got this information right here. So let's go ahead and solve it. Remember when we had 3 variables and we were solving these, or when we had 3 pieces to this in an earlier section? If we want to isolate the x, we'd add 5 to all 3 places. And then we divide by 2, divide by 2, divide by 2. 1 is less than x, which is less than 4. So the graph then of our solution set is 1, 4, and x is in between. We do not count 4 or 1 because we don't have an equal sign under there. And then we draw a line there. So that's the graphical representation of our original problem up here. So example 2, we have 3a plus 7 greater or less than or equal to 4 in our absolute value signs. So we can read this as the inequality, or the distance between 3a and plus 7 and 0 is less than or equal to 4. Or 3a plus 7 is within 4 units of 0 on the number line. So we can write this relationship just like we did in example 1, but we don't have to do any explanation. We just take this and make it negative and make it positive, make less than or equal to signs, and put 3a plus 7 in here. So when we do it that way, we take off the absolute value signs and we just solve. So we're going to subtract 7. So we've got negative 11 is less than or equal to 3a, which is less than or equal to negative 3. Divide by 3. And we get negative 11 thirds is less than or equal to a, which is less than or equal to negative 1. Okay. Then in order to graph this really easily, we've already got all the information there. So we've got negative 1, and negative 11 thirds is 3 and 2 thirds, so we'll put it down here. And a is between there. So a is everything between here. Let me do it in blue here. And our sides, our endpoints are bracketed because it includes negative 11 thirds and negative 1. All right, let's keep cruising. Example number 3. We have the absolute value of x minus 3 is greater than 5. So what that's telling us is that x minus 3, without the absolute value sign, x minus 3 is more than 5 units from 0. So just put this on the graph here. Put negative 5 here, positive 5 here, and a 0 here. What that means is that x minus 3 is going to be a number bigger than 5 or a number less than 5. Sorry about that. That needs to be x minus 3. Now that does not mean that x is a number less than negative 5 or greater than 5. It means that x minus 3 is a number less than that. So let's write these. X minus 3 is less than negative 5, or x minus 3 is greater than 5. So see what happens there. The absolute value is greater than 5 units from 0. So that means that x minus 3 has to be a number to the left of negative 5 so that the distance between 0 and that number is bigger than 5, greater than 5. So let's say that x minus 3 is negative 8. The distance between 0 and negative 8 is 8, and that's greater than 5. Although negative 8 is smaller than negative 5, the distance from 0 is greater to negative 8 than from 0 to 5, because this is a distance of 5, this is a distance of 8. So that's the thing that gets so confusing, is that even though this number is smaller, the distance from 0 is larger. That makes sense? That's why this one is less than, and this sign is greater than. All right, so then we solve for x. And we solve for x here. Okay, and then if we graph our answer, and so it's easier to graph this at the beginning of the problem, and then our graph of the answer is completely different. So I've got 8 and I've got negative 2. So according to this answer, x is a number smaller than negative 2. So I'm going to round and go this way. This says x is greater than 8. Round greater than 8. And there's my answer. Now this example 4, is very, very similar to example 3 because the sign is a greater than. Now the ones before we did less than signs. But when you have greater signs, things are a little bit different. So in order to take the absolute value sign off, we have to set it equal to, oops, wrong way. We switch the sign on the first one and make it a negative 9. So we take the sign off, we switch the sign, we switch the sign. On the next one, we leave the sign the way it is and the number the way it is. Nothing changes there. So that's key to remember. When there's a greater than sign here, a greater than or equal to sign, we switch it the other way and we change the sign of the number here. And then the other equation, we leave everything the same as it is here. We just take the absolute value off. So let's keep going. 4t is less than or equal to negative 6. T is less than or equal to negative 6 over 4, which makes t less than or equal to negative 3 halves. Over here we have 4. T is greater than or equal to 12. T is greater than or equal to 3. So those are my two answers of what T are. And now we'll graph it. So there, and we've got a 3 and negative 1.5 or negative 3/2. Okay, so if T is less than negative 3/2, that means, less than or equal to, it means we have a squared. And if T is less than, it means the number is less than 3/2. It does not mean that the absolute value is less than 3/2. Two completely different products there. So if it's less than or equal to 3/2, the number T represents is less than. So it's to the left of negative 3/2. This says T is larger than 3 or equal to squared. If it's larger, it's going to be going that way. And that ends up being our answer for example number 4. So that's it for 2.7a, and we'll do a shorter 2.7b.